Hi folks, we're going to take a look at numbers 2C and D from the extra review part 1. Okay, so let's start with part C here. So they're asking us to evaluate these expressions. Now, normally I'd be a bit concerned about these two logarithms having different bases, but because I notice that here I've got 5 and I've got a 25 in there, here I have 3 and 27, I'm thinking I might be able to evaluate these individually. Okay, so my first step is to try to write the input to the logarithm as a power with base 5. Okay, so here I have, well, 25 is 5 squared, and of course cube root is just the same as 1/3. So that's looking good. Okay, and here I'm going to try to write this input as a power with base 3. So we know that 27 is 3 cubed, and square root is just 1/2. And so here, this is looking very good, because here I've got now log base 5 of 5 to the 2/3. Just use power of a power rule. And here I have log base 3 of 3 to the 3/2. Okay, and so here again, remember that when I have two inverse functions that are applied one after the other, they essentially cancel each other out. Okay, so I'm just left with the original input, which is 2/3, and here minus the original input 3/2. So now we'll just fix this up here. So put everything over 6. So we have 4 over 6 minus 9 over 6, which is equal to negative 5 over 6. Okay, so we were able to take this, complex looking expression and turn it into a single rational number. Okay, now there was an error in the answer key, so you'll notice the answer key does have a different answer. Okay, let's move on to this one here. This one here, there's actually no work to do, because we essentially have the same scenario as we had in this step here. Okay, we just don't normally, at least in what we've done, we haven't seen this very often. But remember, 7 to a power is the inverse of log base 7. These two are just inverses of each other, so the same thing occurs. They cancel each other out. I'm just left with whatever the original input is. Okay? Because remember, we have these two properties that say that if I apply either a function first or its inverse, and then apply the other, I get the original input here. So as long as these two functions are inverses of each other, it doesn't matter in what order I apply them, I just get the same input back. Okay, so there's actually no work to do there. Okay, that's it for these.